Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Difany AULIA Rahman, Mining Engineering student, Faculty of Engineering, University of Jember. In this moment, I want to describe a journal from the International Journal of Mining Science and Technology, entitled Blastability Evaluation for Rock Mass Fragmentation in Iran Central Iron Ore Mines. This journal was written by Majid Akbari, Gulam Reza Lashkaripur, Ali Reza Yaraham Dibafgi, Muhammad Ghafuri in 2015. In this research, they investigate the influence of rock mass properties, blast design, parameters, and explosive properties on blast fragmentation. Blasting is one of the main operations in open-cast mining. Blasting operation is influenced by various factors that can be classified into three categories: rock mass properties, blast design parameters, and explosive properties. The aim of this research is to evaluate and measure all influential parameters in blast fragmentation. For this purpose, 51 blasting blocks were selected and their rock mass properties were evaluated by measuring the characteristic of discontinuities in 1,961 meters of skyline. Experimenting upon intake rock sample and measuring P-wave velocity in 1,771 meters of seismic profiles in Choghart, Kadermalu, and Sekakun mines. Finally, the influence of mentioned parameters on blast fragmentation was investigated. The studied areas consist of Choghart, Kadermalu, and Sekakun iron ore mines. These mines are located in Buff Block in very zone of Anarak Buff Kerman. Rock mass is composed of two parts of intake rock and discontinuities. Discontinuities include structure in rock mass such as joints, faults, fractures, bedding, and other weakness surface that significantly influence the engineering and mechanical properties of rock mass. The presence of one or several sets of discontinuities in a rock mass under loading and unloading leads to anisotropy. Also, in contrast to intake rocks, joint rock have higher permeability, less shear strike along discontinuity planes, and higher deformability and lower tensile strike in perpendicular direction of their plane. Furthermore, discontinuities lead to scale effects, and the resulting intersection blocks can lead to instability problems. Therefore, in engineering studies of rock masses, both engineering properties to intake rock and discontinuities have to be considered. The investigation result confirmed the relation between rock mass properties and obtained fragmentation, so that with increase of discontinuities spacing in the rock mass, blast rock sizes increase as well. In addition, as discontinuities persistent in rock mass increases, the size of blast rocks increase too. Studying the effects of discontinuities openings on blasting fragmentation of rock mass also indicate an increasing trend of size distribution of blast rock with the increased discontinuities opening of the rock mass. Results demonstrate that when angles are close to 90 degrees, discontinuities are perpendicular to bench face, the size of blast rocks increases. To study the effect of blasting design parameters, effect of specific drilling and blasting system types on the size of blast rock were investigated. Specific charge parameter was used to evaluate the effects of explosion properties on final fragmentation. Evaluation of the influence of connector type showed that applying nodal system in blasting operation will reduce all present pacing size of blast rocks. Finally, evaluation of influence of specific drilling and specific charge on size distribution of blast rocks indicates that the mean size of blast rocks will increase by increasing specific drilling and specific charge. Thank you for your attention. See you next time.